Welcome to Learning Significant Figures, which is a mathematics topic in chemistry. Let's begin. Two friends, Trinity and Michael, were debating the length of a pencil. Trinity insisted the length is 6.8 centimeters, while Michael said, "It's about 7 centimeters. Then Scott whispered,
"Both of you are correct. The only difference is the significant figures."
Here's the outline for the video. First, we will be doing the meaning for significant figures, 8 rules as well as examples, followed by rounding up or rounding down, then calculations pertaining to significant figures, lastly, questions and answers. Significant figures are also known as significant digits. These are the number of digits in a value that are necessary to decide the accuracy or precision of a measurement. Here are the rules to determine the number of significant figures. Rule 1. All non-zero digits are significant. Examples: the value 5, which is one digit, has one significant figure. Another example: the value 78 has two significant figures, 7 and 8. The value 295.4 has 4 significant figures. Here's a question. How many significant figures are in the value 94? The answer is 2 significant figures, 9 and 4. If that was your answer, well done. Here is another one. How many significant figures are in the value 12.45? If your answer is 4 significant figures, you are correct. Good job. Rule 2. All zeros that are found between non-zero digits are significant. Examples: the value 209 has 3 significant figures. The value 650,907 has 6 significant figures. The value 40.065 has 5 significant figures. Here's a question. How many significant figures are in the value 3024? The answer is 4 significant figures. How many significant figures are in the value 1800.907? The answer is 7 significant figures. Rule 3. Leading zeros, which are zeros to the left of the first non-zero digit, are not significant. The zeros before the non-zero digits are placeholders, so they are not significant. Examples: the value 0.09 has 1 significant figure. which is only the numeral 9. The value 0.0078 has two significant figures. The value 0.00506 has three significant figures. Here's a question. How many significant figures are in the value 0.84? The answer is two significant figures. How many significant figures are in the value 0.060405? The answer is 5 significant figures. Rule 4. Trailing zeros, which are zeros to the right of the decimal point, are significant. The zeros after the decimal point indicate that they have been measured, so they are significant. Examples: the value 8.0 has two significant figures. The number 8 and the 0 after the decimal point. The value 61.00 has four significant figures. The value 208.090 has six significant figures. Here's a question. How many significant figures are in the value 8420.0? The answer is 5 significant figures. How many significant figures are in the value 95.000? The answer is 5 significant figures. Rule 5. Trailing zeros for a whole number that ends with a decimal point are significant. The 0 to the right of a non-zero digit followed by a decimal point indicates that the 0 was measured. Examples: the value 80 point, the decimal point is behind the 0, therefore this value has two significant figures. The value 80 without a decimal point has one significant figure. Only the numeral 8. Here's a question. How many significant figures are in the value 50? The answer is one significant figure. How many significant figures are in the value 420 with a decimal point? The answer is 3 significant figures. Rule 6. For values written in scientific notation as n times 10 to the power of a, the number of significant figures is determined by applying the previous rules only to the value of n. Examples: 1.1 times 10 to the power of 3 has two significant figures. Since we are only focusing on the value of n, which is 1.1. 1.10 times 10 to the power of 3 has three significant figures. 1.509 times 10 to the power of 3 has 4 significant figures. Here's a question. How many significant figures are in the value 4.078 times 10 to the power of 9? The answer is 4 significant figures. How many significant figures are in the value 0.0374 times 10 to the power of 56? The answer is 3 significant figures. Rule 7. Irrational numbers, which are numbers that cannot be written as a fraction or non-terminating decimals, have an infinite number of significant figures. Example: pi is 3.14159 and the numbers continue, has infinite significant figures. The square root of 2 also has infinite significant figures. Here's a question. How many significant figures are in the value pi? The answer is infinite significant figures. Rule 8. For values with uncertainty or errors, the numbers to the left of the plus or minus sign follows the previous significant figure rules. Examples: the value 41.7 plus or minus 0.2 has 3 significant figures, which are the numeral 4, 1, and 7. The value 250 plus or minus 10 has 2 significant figures. Here's a question. How many significant figures are in the value 7,654.9 plus or minus 0.3? The answer is 5 significant figures. Those are the rules. Now we are going to do rounding significant figures. When the digit to the right of the one being rounded to is less than 5, the digit remains the same as the value rounds down. For example, 67.83 rounding to 3 significant figures, which is 1 decimal place. 6 is the first significant figure, 7 is the second significant figure, and 8 is the third significant figure. 3 is to the right of the numeral 8. Since 3 is less than 5, the value rounds down, which we remove the 3. The answer to 3 significant figures is 67.8. When the digit to the right of the one being rounded to is greater or equals 5, the value rounds up. For example, 146.4382 rounding to 5 significant figures. 3 is the 5th significant figure. The number to the right of 3 is 8, which is greater than 5. Therefore, we add 1 to the 3 and remove 8 and 2. Therefore, the answer will be 146.44. Test your knowledge. Round 24.622 centimeters to 4 significant figures? The answer is 24.62 centimeters. Round 870.84 grams to 3 significant figures. The answer is 880 with a decimal point grams. The last section, calculations with significant figures. When two or more measured quantities are added, subtracted, multiplied, or divided, the resulting value will have the same number of decimal places as the value with the fewest number of decimal places, which is the limiting value. Example: 2.95 plus 43.123 equals 46.073. The first value has 3 significant figures, while the second value has 5 significant figures. Since the first value has the lower number of significant figures, it is the limiting value. Therefore, the answer should be to 3 significant figures. The correct answer is 46.1. Test your knowledge. Calculate the following to the correct significant figure: 75.24 grams plus 4.7 grams. The answer, 79.94 grams. The answer should be to 2 significant figures. Rounding up to 2 significant figures, the answer is 80 grams. However, you must put the decimal point for the 0 to be significant. So 80 grams. Summary: all non-zero digits are significant. Zeros between non-zero digits are significant. Zeros beginning a number are not significant. Zeros followed by a decimal point are significant. Zeros to the right of a decimal point are significant. Only the n in the scientific notation as n times 10 to the power of a follows the significant rules above. Lastly, values to the left of the plus or minus sign follows the significant rules above. Thanks for watching. Don't forget to subscribe, like, and share. All the best!